Okay, so example 4, we're going to apply the perpendicular bisector theorem. We are being asked, what is the value of AD? So here's segment AD. Well, it's 3x plus 2. If we can find the value of x, we'll just plug it in. 3 times something plus 2, and we can answer the question. So let's take a look at the whole picture and see what else we might recognize. Well, I see a right angle. So AC is perpendicular to BD. I also notice that C is a midpoint of BD because C is in the middle. We've got 11 to the left, 11 to the right, giving us congruent segments. So that means that AC is also bisecting BD. So just from the picture, we can tell that AC is the perpendicular bisector. So any point that's on the perpendicular bisector will be equidistant from the endpoints. Our endpoints are B and D because we bisected segment BD. Do you see how point A is on the perpendicular bisector? So that means that A is the same distance away from B as it is from D. We know that AB will be equal to AD. They will be the same distance away. So that is our equation. We can set 6x minus 10 equal to 3x plus 2 and solve this equation. When we're solving equations, let's get the x's to the same side first. We've got a positive 3x on the right side of our equal sign. I'm going to subtract 3x from both sides. Subtract it from its like term over there. 6x minus 3x is 3x. Carry down our minus 10 equals, that's a positive 2 we're going to carry down. All right, now we just have a two-step equation. We will add 10 to both sides. We're getting that x alone. We have 3x equals 12. Divide both sides by 3, and x equals 4. Now we might think, oh, we just worked so hard. We're done with the problem, right? We figured out what x is. Well, let's just go back and make sure we're following the directions. What is the value of AD? Well, they didn't ask us for x, but we did need it to answer the question. We can see in the picture that AD is equal to 3x plus 2. Now that we know that x is 4, let's just plug in a 4 for the x. 3 times 4 plus 2, that gives us 12 plus 2, which tells us AD is equal to 14.